All right, we're going to talk about linear approximation, and a linear approximation allows us to predict what's going to happen next. And so a lot of times we'll have some sort of x value that's not very pretty. Let's say something like x is equal to 3.114, and I'm going to use a predictor starting at, let's say, 3, which is really, really, really close. And so 3 is so much of a nicer number than 3.114. And so I'm going to create a tangent line at x is equal to 3 to predict the y value at x equals 3.114. And so linear approximation, just so you know, is very valuable. They use this a lot in the business world when they're trying to predict what future sales might be, or what the revenue is for a company, or the profit, or the cost of something. They'll use it. A lot of times when you in the NFL, they'll have projections on how well the team's going to do for the year. That's what a basic form of that type of idea is, the linear approximation. So here's the steps to help you find linear approximation. First, you want to choose a nicer whole number that's close to the one we want. So the one I want is that ugly one in yellow, and the nice one I wrote in blue. And hopefully they'll give you a nice whole number or a simple x value. Even 3.5 is a lot nicer than 3.114. And so we want to create a tangent line at that nice value. So we don't want to create a tangent line here with this guy. That's what we're trying to predict. We want to create a tangent line formula with our nice values. So let's say if I plug in my x-coordinate and I get a nice y-coordinate of 5. And I create my tangent line. Y minus 5 is equal to, let's say my slope was 2x minus 3. Okay, I'm just making up a random tangent line. I color coordinate it so you can see I'm using the nice value. So step 3 is you want to write the equation of the tangent line in point slope form using the nice x value. Please don't use the ugly x value. Please don't use the yellow. Finally, we're going to plug in our ugly x value, 3.114, into x of my tangent line. I'm plugging in this in for x right here. And I want to find what is the predicted y coordinate, which will be this y value right here as I solve it out. So let's go ahead and plug in. So I would have y minus 5 is equal to 2, and then I would plug in my ugly x coordinate, 3.114, subtract 3, and then solve for y. And so that solution that I found with my tangent line is my predicted value for my x coordinate at 3.114. And so way we evaluate how well my prediction is sometimes we have underestimations or overestimations. So let me draw a quick graph of what I mean. If the y value in my tangent line is greater than the y value in step 4, then it's an overestimation. So if I have, with my function, if I actually found f of 3.114 and I compared it, wrong color, and I compared it to this y coordinate right here, if my function is greater, than my predicted, then it is an underestimation. So here's my blue point. Here is my yellow point. And here is my tangent line. as you can see, my tangent line y value, I'll put it in red, is less than my true y value, which is in yellow. Okay, so that would be an example of underestimation. Let's suppose my tangent line is greater. So the y value of my tangent line is greater than the y value of y of 3.114. That means that my graph looks something like this, where I have a curve like that, and we'll do my y point here. My true point is here. We'll go ahead and draw our tangent line. And in red, again, here's my predicted point. And you notice that my predicted point is greater than my true point. In this case, we call it an overestimation. So let's go through several examples. Number 1, find a linear approximation for f of 2.1 if f of x is equal to 6 over x squared. Is this an over or underestimation? And we're going to justify. So we're trying to approximate 2.1, the y coordinate of 2.1. So how about we pick an x coordinate that's a lot nicer? So this is my ugly x coordinate that I had in yellow above. Okay, that's my ugly x coordinate. So I need to pick a nice x coordinate to create a tangent line from. So I'm going to pick 2 because 2 is really close to 2.1 and it's a lot nicer to work with. And so if I was going to plug 2 into my other equation, I'm going to get 6 over 4, which is 3/2. Okay. And so I want to find what is the tangent line for my blue point. I'm going to create I'm not creating a tangent line for my yellow point, my predicted point. I want to use my nice coordinate to predict, so I need to kind of step back a little bit. And so I'm going to find my f prime of x. And if I was going to, let me undo that. Let's change f of x so it's in power form. So it'll be 6x to the negative 2. That means my derivative is going to be negative 12x to the negative 3. So let's find our m, our tangent line. So it'll be f prime of 2 is equal to negative 12. And again, if this right here, my exponent is negative, it means it's from the denominator. So I'm going to return it to help me out. And so I have 2 to the third. Well, this is negative 12 over 2 times 2 times 2 is 8. So if I was going to simplify that, that would be negative 3 over 2. And so now I'm going to go ahead and create my tangent line. So my tangent line, I'm going to write in green so you can see it better. It's going to be y minus 3 over 2 is equal to negative 3 over 2 times x minus 2. So I'm going to use this equation. I'm going to use that equation to predict what the y value is going to be. So I'm plugging in, and see how I still have it boxed in yellow? I'm going to plug that in to my x coordinate, which is right here. I'm still using the same equation that I just made in the red box. So I have y minus 3 over 2 is equal to negative 3 over 2 times, and here I'm plugging in that ugly x coordinate, so 2.1 minus 2. And if I solve that out, I'm going to get, and that is equal to 1.35. So now let's find what is really f of 2.1. And that's going to be equal to, that's a little hard to see, let me fix that real quick. F of 2.1 is going to equal, okay, I just want to use my calculator. I have 1.360. And so since my estimated value is less than my true value, then I'm talking about an underestimation. Alright, number 2, evaluate square root of 39 without a calculator. Use linear approximation, and we want to know if this is an over or underestimation. So I'm going to pick a perfect square that's really close to 39. I'm going to say 36. So I'm going to pick an x-coordinate that's really close, 36. And you notice I'm using, you'll notice that f of x, you can tell what the parent function is going to be the square root of x. So f of 36 is going to be equal to 6. So now let's go ahead and find our derivative. So the derivative, let's go ahead and put this in power form. This will be x to the 1/2. F prime of x is going to equal to 1/2 times x to the negative 1/2, or which would be 1/2. And again, I'm going to move this to the denominator because it's negative, and half comes from the idea of a square root. So the idea is I'll be 2 times the square root of x. Well, f prime of 36 is going to be 1 over 2 times the square root of 36, which is 1/12. So I'm going to go ahead and write my tangent line. So it'll be y minus 6 is equal to 1 over 12 x minus 36. And I'm going to plug in my ugly x value, which we're looking at. So here's my ugly x value. It's 39. So I'm going to plug that 39 in for x and use my linear approximation to approximate what is the square root of 39. So I have y minus 6 is equal to 1 over 12 times 39, my ugly x value, minus 36, and that will be y minus 6 is equal to 3 divided by 12. So I have y is equal to, if I add 6 both sides, 6, and then 3, this would be 1/4, so 6.25. And if you actually take the square root, of 39, you get approximately 6.244 and so forth. And so you notice that my linear approximation is pretty darn close. However, my function, my approximation, is greater than my actual value. And so since my estimation is over, it's going to be an overestimate.